Hi everyone, welcome to lesson 23.3, Graphs of Logarithmic Functions. Today we're going to need the lesson 23.3 note sheet, which is posted in Google Classroom, and you'll want your pen or your pencil. We are going to be finding key features of logarithmic functions, and then we are also going to identify transformations of logarithmic functions. So before we get started here, focusing on just logarithms, what I want to do is look at the function f of x equals 2 to the x, which is exponential, and then look at its inverse, g of x equals log base 2 of x, which is obviously logarithmic. Okay, so we're going to kind of compare and contrast these two. Okay. So looking at our first one, 2 to the x, it's graphed here from Desmos and also has the table. So first thing, let's find the x-intercept. Well, remember we have, when we talk about exponential functions, we have a horizontal asymptote. So maybe we'll just write HA there for horizontal asymptote. And so there actually are no x-intercepts, so we would put none. Okay. And then our y-intercept, we can tell, is here at 0, 1, or you can see that here as well. So our y-intercept is at 0, 1. Our domain, so this is something we talked more about end behavior rather than domain, but our domain here is going to go, that's your x values. So it's going to continue going left for forever and continue going up and to the right for forever. So since it continues going left and right for forever, our domain is negative infinity to positive infinity. Okay. Our range, however, because of the horizontal asymptote, this is not going to go below 0. So we would say from 0, because it's not going to go down any further. So we would just say from 0 to positive infinity, because our range is going to go up. Okay, so remember, domain is left and right, range is up and down. So from 0 to infinity. Okay, and then last thing, we said our horizontal asymptote is at y equals 0. Okay, because it hasn't been shifted up or down or anything like that. Okay. So now let's go ahead and look at this information for a logarithmic function, which we have not dealt with yet. And first thing here is that we can see it's kind of going in a different direction. It's an inverse, okay? So actually what's going to happen is now we are going to have a vertical asymptote, and you can kind of see that it tapers off going vertically. So we're going to call that a VA vertical asymptote. Okay, and now we also have an x-intercept, and that is at, 1, 0. Okay, but now because our vertical asymptote is the y-intercept, now we will have none for the y-intercept. Okay, then our domain, okay, so now if we look at this, domain is going to be, again, from left to right. Well, we cannot go any further left than the asymptote, and then it's going to go towards positive infinity. So we would say 0 to positive infinity. And then our range is going to be, remember, that's down and up. So this is going to continue going down for forever, so negative infinity. And then this is going to continue to slightly move up for forever, so positive infinity. All right. And then the last thing here would be to look at the asymptote, which again, it's a vertical asymptote. So now we would write that as x equals 0, because it's going through the x-axis at 0. Okay. So now looking at a couple similarities here and differences between an exponential and a logarithmic inverse functions is that everything just kind of flip-flops. So your x and y intercepts just kind of flip-flop. In an exponential, you have no x-intercept. In a logarithmic, you have no y-intercept. In an exponential, the y-intercept was 0, 1. In a logarithmic, the x-intercept is 1, 0. Okay, same idea with the domain and range. Okay, In an exponential, your domain is negative infinity to positive infinity, but in a logarithmic, your range is negative infinity to positive infinity. And then in both of them, we had 0 as our asymptote. Just one of them is y equals 0, and one of them is x equals 0. One of them's horizontal, one of them's vertical. And that affects the range in your exponential and the domain in your logarithmic. Okay, so that's what's pretty cool about these two functions being inverses of each other, is they do have quite a few similarities, but a lot of the things are just flip-flopped or reversed because they are inverses of each other. Okay, so that being said, your transformations are going to be very similar. So you have your A value here, and that's going to tell you if there's a vertical stretch, it's going to be greater than 1. And if there's a vertical shrink, it's going to be a fraction between 0 and 1. And if it's negative, it's going to be a reflection. Okay, all of those are the same as what we've dealt with before. Okay, if there's an h value, you can see that there. If it's negative h, it moves to the right. And if it's positive h, it moves to the left. And then this is going to be what helps you with your vertical asymptote. Okay, when it's the plus k for an exponential, that helps you with the horizontal asymptote. But now because it's moving left or right and we have a vertical asymptote, the h value is going to help you. Okay, and then last you have your plus k, which is going to move it up or down. If it's positive, it's going to go up. If it's negative, it's going to go down. Okay, and then last thing here, this little b, that is your base of the log function. Remember, we say log base b or log base whatever it is, and that's not going to cause any transformation. Okay, so it's really the same ideas as transformations we saw with exponential functions. So let's go ahead and try some. Okay, so the first thing you're going to do here is you have a logarithm, and you are going to state what the transformations are. Okay, so in this one, we have log base 2 of x minus 1. So the only thing we can say here is that x minus 1 moves it to the right 1. Okay, so that's also going to move your asymptote to the right 1. So instead of being at x equals 0, we now can see we have an asymptote at, x equals 1. Okay, then let's take a look at our domain. So remember, domain is your x values. So that should go from your asymptote at 1 to positive infinity, because this is going to keep moving to the right for forever. Then here's a quick little hint for you guys. The range for a logarithmic function is always going to be negative infinity to positive infinity. And that's it. That's all we're really looking for right here. Okay, so we talked about the transformations. We know where the asymptote is, and we know the domain and range. Okay, let's go ahead and try another one. So again, looking at this one, we have log base 2 of x. And the base 2, if you read up here, identify the transformations of the parent function. So the log base 2 is your parent function. Okay, so you're identifying what transformations there are from that, and it looks like it's just the plus 2. So that means it's going to move up 2. Okay, so because there is no h value and it did not move left or right, that means that we, are not going to have any type of, we aren't going to have any difference in your asymptote. So your asymptote is still going to be at x equals 0. So we have, man, everything's moving around on me. There we go. So still at x equals 0 because it did not move left or right. Okay, so your domain would still be 0 to infinity, and your range would still be negative infinity to positive infinity. Okay. All right, so I want you guys to pause the video here and try this next one out. There are a few more transformations on this one, so be careful. List them all out, and then go ahead and answer the questions about where is the asymptote, what is the domain, and what is the range. All right, so hopefully you pause the video and this is what you should be looking at here. So this negative out front tells us there is a reflection. This +2 tells us it's going to move to the left 2, and this -3 tells us down 3. Then, because it moved to the left 2, that means that our new asymptote is going to be at -2. So that's where x equals -2 came in. Then your domain is from that -2 to positive infinity. And your range is always going to be the same for a logarithmic function, -infinity to positive infinity. Okay, beautiful. Then the only other thing we're going to talk about here are natural logarithms, which have all of the same transformations. The only difference is the base is e, which does not need to be written, and it's written as that ln instead of log. Okay, so this one, our shift is going to be down 2 because of that -2 at the end, which is not going to change your asymptote. It's still going to be at x equals 0. And then your domain is still going to be 0 to infinity. And your range is still going to be -infinity to positive infinity. So nothing really changes. We just know that, again, the base is e, and it's written as a natural log. Okay, let's try another one here. So to identify our transformations, we've got that negative out front, so a reflection. Whoops. And then we've got this +1, which actually means it's going to move to the left 1. Remember that? So then our asymptote is now also going to move to the left 1. So that is going to be at x equals -1. Then our domain is going to be -1 to positive infinity, because this one is moving, can keep going to the right for forever. So -1 to positive infinity, and our range does not change, -infinity to positive infinity. Okay, so again, this last one, I'm going to have you guys try that on your own. So you have the natural log of x minus 3 minus 5. State your transformations, state where the asymptote would be, and then state your domain and range. Okay, so hopefully you guys did this one, and it should move to the right, to the right 3 because of this x minus 3, and then it should move down 5 because of the -5. Okay, because it moves to the right 3, that's where your new asymptote is going to be at x equals 3. That's also what your domain will be from 3 to infinity. And then your range is still going to be -infinity to positive infinity. Okay, so that's it for graphing. Again, if you are not given the graph, what you can do is just plug it into your calculator or Desmos. But other than that, you should be able to find these transformations and find these key features of logarithmic or natural logarithmic functions. Okay? Any questions, leave them here or bring them to class tomorrow. Bye-bye.